Dog, as I may mentioned before, I'm a freshman here at Carroll Morgan School. It is my honor this afternoon to be presenting to you today's speaker, John Liu, the Director of Environmental Education Media Projects, an award-winning documentary filmmaker who's here to address with us the topic of Earth science. Mr. Liu's an expert on the Earth's degraded and pristine system in all its contents. He studied up close the importance of biodiversity, the importance of weather, and the climate. The more the Earth evolves, the more we learn from it. We learn how everything is interdependent. He's here to teach us about what we can learn and how we can help and improve the ecological health and prosperity of our own community. Now I will hand it over to Mr. Liu to elaborate on the topic. Ladies and gentlemen, please welcome him. Thank you.
Well, that's a very nice introduction, but actually I'm on an inquiry, and I've been on an inquiry that's lasted about 20 years so far. So I think I'm kind of slow. I don't think I'm an expert. I'm just a very plodding sort of a scholar. So I do want to talk to you about a few things. Can you hit the button for me? So, as you know, we're facing climate change. So this wasn't exactly what happened to me in the beginning. What happened to me was I was asked to go to the Loess Plateau and film a large degraded ecosystem. But as I began to study this, I found that as our hostess said, everything is interconnected. And what I found was a historical landscape that had been destroyed. And I started to wonder, like, how is that? And I found that it's connected to climate change. So you may have been, I'm sure you've seen Al Gore's film maybe, or this kind of stuff. So you know, hit the button, you know the Keeling curve, probably. This is actually showing that the Earth respirates and what the carbon levels are, and we are at dangerously high levels now. So this is suggesting that we're already going to experience 2 degrees centigrade changes in the temperature. And actually recently in El Salvador, their measurements are suggesting that Central America's temperature changes are twice the global averages. And their experiences of extreme and erratic weather events are doubling every 10 years. So this is quite serious. But one thing that seems to have been communicated by the Al Gore film and others is that emissions of carbon dioxide and other greenhouse gases are the major cause of climate change. And there is evidence that CO2 has massively increased. But what I'm seeing is that we've also done something else. We've decreased the ability to absorb carbon into the plant life and into the soils. Now, it turns out you have several carbon sinks. The largest carbon sink is the calcium carbonates in the ocean. And when you consider this, these are all photosynthesis, because phytoplankton is the beginning of the food chain, and it builds up into the skeletons and the exoskeletons, and they drop down to the bottom of the ocean, and that's this calcium carbonate layer that's been there for prodigious time. That's the largest carbon sink now. But you can also imagine that all the coal, all the oil, all the gas was photosynthesis. And then you have the second largest sink, which is the soil carbon. So this is, when I started to understand this, I went to the USDA and the Geological Survey, and I found that they're studying, but it's in its infancy. So if any of you really like science and you want to go further, microbiology is a very interesting subject. These are filamentous fungi. So they're fungus systems, and they create and secrete a polysaccharide sheath around the filament. So the filaments themselves are rather tender, but they secrete a polysaccharide sheath. It's glue, polysaccharide. It's, if you study chemistry, this is glue. It's holding the earth together. So if you destroy the microbiologic habitat through exposing the soils to UV radiation, which sterilizes the surface, or you remove the ability for them to recycle because they have no organic materials to live on, then you get desertification. So that's part of the desertification process. So that's what we saw and this area in microbiology, they weigh them. They barely know the differences in the bacteria. It must be enormous. You have millions of bacteria in your body. You're living symbiotically with bacteria all the time. It's not that you need to sterilize everything and you need to study this. We don't know enough about this. The other thing that I've seen is that every pristine place that I go has enormous amounts of organic materials. Huge. You can't even walk. Now we're standing in here, and there are a large number of bipedal primates in the room, but there's just sort of 6 or 7 or 8 little plants here. So this is more or less a biotic environment that we're in. This is a biotic environment. This is what's missing. So in urban areas, in industrial areas, even in industrial agriculture, this is what's missing. And this is what you find in natural systems. So that what I've come to see is that the percentages and the total amounts of organic material are connected to the percentages and total amounts of biomass, because each generation of life dies and lays down its body. And in doing that, it's feeding the system. It's recycling. What I noticed too is, did anybody ever think about reincarnation? So you hear that sometimes, and I was thinking about reincarnation. I came to the conclusion that reincarnation is not a theory. The cells in your body are not just similar to the cells that were in other organisms. They're the very same ones. That's the only way possible. And all of you, all of us, are representations of all life since the beginning of time. That's the lesson of genetics. So if we weren't, we wouldn't be here. So this is very important. Now, what I found was all of these things, there are these major trends. The trends that I started looking at were the total colonization of the planet by biological life, the enormous growth of biomass to reaching up to climax systems. And so this is not a popular phrase in ecology right now, but climax to me is something which is important. It's not a static state. It's a dynamic state. But it's something that we are not seeing because we're not allowing the vegetation, the biodiversity, the biomass to reach its climax. So we're cutting everything off and we're miniaturizing everything. And what I see in the natural states is enormous evidence of giantism. Huge, huge, huge thing. In the Oregon Andrews Experimental Forest with the Forest Service in the United States, 95-meter high canopies. But this is very rare, and we're not allowing trees to get to 800 to 1,000 years old anymore. And what I also found in California, the grass root systems are 1,000 years old. So the grasses, perennial grasses, are as old as the trees. But we're plowing, we're killing them. So this is what's created the atmosphere through all this enormous respiration that's taking place. And that's what you see in the Keeler curve, is the CO2 uptake and the CO2 release. But if you reduce the canopies by enormous amounts, you reduce the amount of oxygen which is released, and you release the amount of carbon which is taken up. Now, in these huge, huge canopies that we have now, go out and look at the city. I can't look anymore without noticing the difference. So when you go to the city, you go to the industrial area, you go to the farms, you don't find this. You don't find these kinds of streams which are laughing at us, and they're happy and they're clean. You find seasonal streams that only run when the rainy season, and then because they don't have all this vegetation around them, they don't infiltrate, they don't have this huge amounts of organic material, they don't maintain it. These are like sponges. Everything is moist, and it's wonderful. This is wonderful. But if you do the wrong thing, you get this. So over vast areas of the planet, this is what I find. So I find this all over the place. And then this is how the streams flow. In the rainy season, because they're filled with sedimentation. And this is just a massive dysfunction. So I see massive dysfunction on a planetary scale all the time. And it's completely unnecessary. And it's not even that difficult to address, but if you don't address it, it gets worse. So if you measure the sediment loads here, and then next year you come back and you measure the sediment loads again, you'll probably have more sediment loads. But if you measure the sediment loads and you say, oh, massive dysfunction because there are huge sediment loads here, and you go upstream and you replace the vegetation, you'll never see that number again. So the highest level of this functionality that I've been looking at is biodiversity. So a lot of people don't understand biodiversity. I think they look and they want it to be tigers and elephants or something. But I think what we're seeing is that there's an infinite potential variety in genetics. You don't want to reduce this potential. And it's all in a web of life. It's all interconnected. You can't separate this. If you say, well, I don't know what that is, and you kill it, that's the height of arrogance. That's to say, well, I don't know what that is, and I'm ignorant, and I'm a violent, ignorant person, and I'm just going to kill that. And we've been doing this now for thousands of years. We need to step back. We need to think, do we know anything about this? Do we understand science at all? Do we understand genetics? Now we think we understand genetics to the point where we're going in and manipulating the genes. This is outrageous. We don't even understand or stand in awe of the amazing diversity, and we want to go in and say, well, I just want it to be like this. Well, that is really dangerous. If somebody had done that 200 million years ago, we might not be here. So we don't want to limit the potential. And the hydrological cycle, the carbon sequestration, the atmosphere, the food security, they're all the same thing. There's no difference between combating desertification and mitigating and adapting to climate change or protecting biodiversity. It's all the same. But it's very difficult for us to get our minds around this. And my feeling after going there to so many places around the world is that whatever we know, the more we know we don't know. So I didn't understand anything about these things, and I went out and took pictures of a ruined landscape. And then I slowly went around the world asking the experts and filming them and interviewing them and filming these places. And gradually I came to a feeling like I sort of understand this, but something's happening. Something's causing the destruction. And it's not simply understanding this that's going to save it, because we're actively destroying it. And what I realized was that there's a difference between the natural environment and the built environment. But we have weighted the built environment and said that it's more valuable. And this built environment very rapidly turns to crap, you know, almost. But, you know, really, the natural systems are so amazing. And the built environment is junk. And we're looking in the wrong way. We're missing this. And we're speculating on things, and we're believing that they're technological fixes to everything. But in fact, they're not. A biochemical photoreactive process that created the atmosphere, the hydrological cycle, regulates the Earth's climate. We can't make a machine to do this. We can't put iron filings in the ocean or paint the sky or get in spaceships and go to another planet. It's not going to happen. We live here. And anyway, why would we destroy paradise? Why would we do that? So we really need to get our mind around this. So I thought we could talk about whatever you want to talk about now. We have some time. And I got to say what I wanted to say, so who wants to talk? I see some science teachers back here. They should be telling us stuff.
I'll start.
Okay.
When I teach science, no matter what the subject, I often am quoting to my students, nature's pretty damn smart. And I had it, I think pretty much all humans seem to have this genetic need for what you call paradise, the natural system in its natural state. I'm wondering if you think that, you know, in our genes themselves, we're programmed to know the answer.
Yeah, I mean, I'm interested in this because I've been asked to speak around the world. So I've spoken in the Middle East, and in Europe, and in Asia, and in Australia, North and South America, and Russia, everywhere. And what's interesting is everyone can accept this. This is the knowledge which brings us together. So for that, like, if we're thinking of the future, or we're thinking about how to make the world more fair, how to address some of these leftover problems that we've got from history, this is what brings us together. So I totally agree with that.
The question that I've been thinking about since this morning when you spoke is that in the land in places like China and India that we showcased this morning, one, who owns that land, so how can it be preserved? Does it become conservation land? Or two, I come from Chicago, so a word like gentrification is a word big in my head in urban systems. So my question is, once these areas have been restored was to keep someone from saying, wow, this rich, lush area, let me buy this land, farm it, use it, and repeat that cycle until we screw it up again and then have to do it again. Because that's how Chicago neighborhoods work. And, right?
Yes.
I'm sorry.
You were so right.
And I was a community developer and organizer before this, and that's the whole discussion of how do we sustain a community.
I heard that Zach, whatever his name is, introduced Obama as a community
Organizer, Galvanic, exactly. But so that's my question is like, if those lands are put into trust, then that makes sense, or if they're owned by a municipality, but that can concern them or whatever. But if they were once farms, then aren't they owned by
Well,
someone?
no, the question that you're asking is about land tenure
Yeah,
and the rights or the security of the rights of people so that they will make investments and spend time. I think this is a really difficult question because I don't think there's an actual really easy answer. If you, here in Central and South America, in all of the Americas, the natural systems were more well taken care of by the native peoples before these areas were invaded. And the native peoples' cosmology doesn't allow for ownership of land. So I think it's not easy just to say that if somebody owns it, it's going to be better taken care of. The other issue is if somebody owns it, and now you have we have 7 billion people and we're adding 1 billion people every 12 years. What happens to people who don't own anything?
right.
And what happened? How did somebody own everything and they didn't own anything? And what happened there? So I think these are the hard parts. These are the really hard parts. But you need to have some sort of method to engage everyone in restoration. If everyone's efforts go to restoration, then actually you're going to have a much better time because the stress levels in the modern society are too high, and the depression levels and the suicide levels and a number of problems there. So that's not making people happy because they have more cars or television sets. And what you do see in the developing world, strangely, is that the life expectancy is much shorter. The sort of income levels are much shorter, but there's somehow more satisfaction. Less, I see children and people, they look you straight in the eye and it's interesting. And they may not live as long, but they may be happier, somehow more satisfied. They don't get up in the morning wondering what's the meaning of life. I think they feel something greater than that. Yeah.
Earlier in your first presentation,
Okay.
I'm sorry, no,
No, you start. Go ahead.
Alright, apologies. In your first presentation, you were talking about restoration, and I thought that was really, really interesting. It actually gave me a lot of hope, and it was great. The examples you gave, though, were these societies that were very impoverished, and you were sort of building from the ground up. They were looking for an answer, and you were able to implement the strategy, and it was able to happen in a number of years, a short number of years. Like you showed those 5-year later pictures, and it was amazing to see. But how do you translate that idea to an urban system, to a system that's like speech kind of like capital and things like all of these notions, and it's just how does that translate? Do you just hit a wall, or?
Well, I think you either evolve or you hit the wall. So I think the question now is if you plot trends. Are math teachers here? Because if you're teaching math and you start to plot these trends, then it isn't going to work out, and that can't make. Any high school math scholar, it can make them very happy. Because where's my job in that, in that curve? It's dangerous. So, in China, it's a terrible curse to say, may you live in interesting times. It's better, to sit in the backyard and drink wine and write poetry to the moon. You don't want interesting times. That means there's going to be war, there's going to be all kinds of terrible stuff. So I think we're in interesting times right now. So we need to get our mind around this. And if we don't take care of some of these things, then they will happen. So I would say one of the things, and your question specifically about urban areas, have you looked at Detroit lately? Because it's interesting, if you look at Detroit, there's something happening where everything collapsed. The economy collapsed, people left, and buildings are falling down, there's a gang warfare, and it's weird. But then there's this movement to do urban agriculture and to rebuild houses and communities. And people with tremendous morals and physical strength are doing it. And that's interesting to me. Because maybe that's what, and when you look, if I go to a place where something happened, and you look at how the plants, they're breaking through all of the concrete. The concrete disappears within short periods of time. You can hardly find it. And that's what's going to happen to the earth. The earth will be okay. It's human beings and our civilization that we're really fighting for. So I think, human beings have made certain strides, and we ought to fight for this civilization. We shouldn't let it go down. The idea that we're a zombie in a moment, we're going to disappear, that's ridiculous. Yes?
And you say in your presentation that in Salvador, Central America, that the temperature and climate change was affecting more in that area. What's the cause of that?
Why is that happening?
More, you said it's double.
Yeah, no, well, the extreme weather events are doubled every 10 years. And the temperature increases are twice the global average. Those are the two figures that I quoted.
So the question is, what would affect what's the things that affect it? In Central America, twice like double
The reason is that it's in the equatorial zone. So there's going to be some difference in different parts of the earth. So this area actually it always has amazing change. So the equatorial area is, but if you go back in historical times and look at fossil records, it changes. And so, if we expect this kind of super carbon, high density atmosphere, well, that's probably going to kill us. So I'm not sure that I want to think about that. But anyway, if you go back in the fossil records, you can see times where there were massive changes like this. And that's when you had species die-outs. And we're in the massive species die-out, and we are at the top of the food chain. So in a species die-out, the top of the food chain is badly endangered. So we're in danger. But I think what I would say to this is, you need a robust community. You need the most natural regulation you can get. So that means you don't want the least amount of organic matter and tiny, puny biomass. You want gigantic biomass and huge amounts of organic matter in order to regulate the hydrology and the weather and the climate. You want mangroves, huge mangrove systems. When that tsunami comes in, they bend, but they don't break. And that's what saves you. I'm sorry, there was something.
Yeah, actually, adding on to this question, if countries like China and India and we saw even in Africa, if they have been very successful in restoration, why aren't the developed countries following the same methods if it's out there? I'm sure that deforestation happens everywhere, and
I think what's happening is if you go to New York or to London, what's happening now is that somebody makes a small bet between the cost and the price of a commodity. And because that commodity is spread out all over the world, then if he wins, he makes millions of dollars. So you can have somebody in the developing world who's working in the field making the commodity that guy is trading, and they make nothing, pennies for all of their work. So we've done something, the system is inherently unfair. And it's kind of hard to put a happy face on it. You know, we think that, you know, wealth is the accumulation of material things. But actually, we're getting cancer rates, we're having climate change. The financial system itself is in danger because it's actually unworkable. So you have a major problem, it's unworkable. So that's a problem. You probably can't just fix this. That's why I think the restoration economy is something which is a really good idea, because it engages people in something that you know is going to make life better for everybody. And it means that our work doesn't hurt anybody. So like if I decide I'm going to go be a trader and I trade this stuff and I accumulate more and more wealth to myself, there's a lot of people I'm hurting out there. I don't think that's a good thing. I don't want to do that.
When you were in China, you were involved in working with the people to change their value system, right? They changed what they value.
We have to be a little careful when we're wherever we are. We're a guest. So I'm a guest here, and I'm a guest in China, and I feel like I'm a guest everywhere. So I try not to go in and just say, I think I know everything better than you do this. But what we do is give them a lot of information, and then ask them, can you make up your own mind?
And so that value, or that value, it seems like the world values the economy more than the environment, and even more than each other right now, right? And a true sustainable environment values all three of those, right? You value the environment, you value the economy, and you value society.
Yes. I think the economy is misdefined. So there is no economy without a functional ecosystem. It doesn't exist. And that's probably true also for the society and the civilization. So if we don't have air, water, food, and energy, I think we're done. So, it's really like a decision. What do we believe? The math is too good. The numbers are too compelling. 7 billion, we're adding 1 billion people every 12 years. The energy use, the water use, it's not possible to carry on with the wasteful, destructive way that we have been. And it's speeded up now. So you can have, if it wasn't for China and India emerging from poverty and isolation and accepting sort of capitalism and market forces, then you could keep it going another 100 years. But now, it's happening now. So it's not possible. The math is too compelling. I'm not very good at math, but I can tell you it isn't going to work out. I can't tell you down to 12 decimal points, but yeah.
So before we desolate areas, how do we act? My question is in regards, I work in Mexico City. We go to a camp a few hours northwest of Mexico in a town called Valle de Bravo. And for the last couple of years, we've been doing an ecosystem study with our 7th grade biology students there, where they find a fully natural ecosystem in that area, like a river, and forest, and we compare them, and they draw them, and whatever. And this year, when we went up to camp, to the river, it was all cloudy and murky, and it had been one of your beautiful, babbling, little, never deeper than your shins, kind of streams. And now it's murky, and so that's what we're figuring out, but, there's different bugs than there were before, and the vegetation's a little different. And the science teacher who's been going there for more than 10 years is so upset.
Yeah.
And so, though the camp hadn't even noticed because the river's still moving, but she just compared last year's to this year's, just the drawings and the observations. So we've been trying to research what's happening upstream that this spot has changed. And how do we then say, we know you didn't cut off this river, we know the river's still flowing, but whoever's doing whatever they're doing north of here has now started affecting the ecosystem. And
We all
we don't
live-
like it.
we all
how do
live downstream.
right. And how do we do those incremental stop that before we come back next year and there's no stream at all, or the stream has, no living life in it? And who are those watchdogs? Like, I'm lucky that there's a 65-year-old biology teacher who's aware of what that stream looks like, what it's looked like for the last 10 years, because I wouldn't have known.
Well, I would recommend, what we're recommending around the world is research, training, and innovation centers for ecological restoration. And the concept is that whoever understands it has to do it now. And others who don't understand it, then they're gonna find out. I mean, I was thinking about this with somebody today. What happens if New York City doesn't have electricity for 2 weeks? What happens if the long distance food transport systems or the water supply, this is a different kind of jungle. And that's where the zombie visions are coming from. And that's a post-apocalyptic thing, and it's so close. I think it's a real close thing. Detroit, when you look at Detroit, it's fascinating that people just abandon the thing. They just go away. They can't live there. They don't know how to. But what we're now seeing is that work is not honorable. Work is to make money, and work has to become honorable, and people have to work together. So now the message is compete, get more than anybody else. Well, that's no longer a viable option. So it could be legal for somebody to amass huge amounts of wealth, but it can't be right because you've got billions of other people and they have rights too. So, I mean, I think we learned this in kindergarten, really, that we're even talking about it in higher education. It's kind of sad, or in the society itself. We need somehow to create successful communities. Those communities must be robust. They must be respectful. They must be environmentally and ecologically functional. And that makes it more robust so that when extreme weather events happen, those are the places which survive. So we started to see this now outside of Beijing. So in China's had lots of pollution episodes and all these food crises and stuff. So there's one guy, I hope to do a TV show about him. He said, we're gonna do biodynamic agriculture. If you know what biodynamic agriculture, this is connected to Rudolf Steiner. It's the highest level of organics. It's intense. So they're a little esoteric. They stir one way during one phase of the moon and the other way during the other phase of the moon. I never quite understood that. But what I see happening, because they came to my place and they said, oh, you have a lot of, I see you built your house over construction rubble. Yeah, we did, we haven't been able to grow too much here. So the guy says, well, let me fix this up. And so he says, stir this way. I started stirring, he said, no, stir this way, you know, and I have to stir. We're stirring, and then he mixes it down to a very little thing, it's called potentizing or something like this. And then he spreads this stuff out. And I'm thinking, this isn't gonna work. And then boom, everything is just bursting out. And I started to look at what I think is happening in this. They're stimulating microbiologic communities. So whatever they're doing, they know they've been doing it since 1920 something. They have no fertilizers, they have no pesticides, no chemicals of any kind, and they just know something. So it's esoteric, but it's not a cult, and you know it is interesting. And I think there's a scientific explanation for what they're doing. So I think they're stimulating microbiologic communities, and those microbiologic communities are doing huge amounts of work. I saw this there's a much more scientific study with the Lawrence Livermore Laboratories in Marin County in California. So I went out there and I looked at what they were doing, and they were making humanure. So this is human feces turned into compost, and then they couldn't use it for agriculture because it's not allowed in California, although they do it in Haiti. And they do it in China. They do it all over. But what they did was they made a application of this humanure on a grassland system, a 1 hectare by 1 hectare plot. And then they measured the carbon increase in the soil year by year, and they got 5 years of enormous increases. Like every year, the carbon would increase. They made no further applications. So that suggests to me that the microbiologic communities are stimulated, and then of course you don't cut, you don't plow, you don't take out the organic materials. So you have to start to realize what this means, because even in our cities, in the cities we have like crews that go along and put trees and grass in and flowers, and then they cut everything down and rake it all up and take away the organic material. And I look at that, what are you doing? You don't understand. You need a huge, huge organic layer. And here you have actually nature starting to do what it wants to do, but you want to clean it up because you don't understand the function. So, well, no, I don't think so. Anybody want to go? Where are we going to go?
Okay, sorry. I didn't want to cut you off. So I'm sorry. It's intriguing, really. So everybody needs to go. I missed that. Everybody needs to go find their advisor before you.
Sit down.
Please. We're here. Okay, so find your advisor and head over to the buses where you came from.
1, 2, 3.